Hi, my name is Akseli Seppälä, and I'm going to present to you my research on AI ethics and AI governance. It's called From Ethical AI Principles to Governed AI. This research was conducted together with my colleagues Teemu Birkstedt and Matti Mäntymäki at the University of Turku, and it's a part of the AI Governance and Auditing research project, which is financially supported by the AI Business Program of Business Finland. Before we begin, I would like to ask you to think about what you know about ethical AI or AI governance. If you're familiar with the subject, you could have thought about ethical AI principles such as transparency, explainability, fairness, non-maleficence, accountability, and privacy, or some guidelines or frameworks how to implement these in practice, such as the European Commission's high-level expert group on AI's ethics guidelines for trustworthy AI, or the IEEE document of ethically aligned design. These are, of course, only a few examples. But do you know how these are, in fact, implemented in organizations? Is this just something for the academic world, or do these translate into practice or have any practical implementations? The extant literature offers nascent insights how organizations implement and deploy AI in a socially responsible way. Indeed, to date, the research on AI ethics has been mostly conceptual, with a significant emphasis on defining the principles and guidelines of ethical AI, while the empirical research is still scarce. So we don't actually know how organizations are addressing these ethical principles. What makes this subject even more relevant is the European Artificial Intelligence Act proposal published by the European Commission this spring, which underscores that there is a momentum for a shift from principle-based ethics towards an increased emphasis on the implementation of ethical principles in practice. To address this gap, this study answers the following research question: how do organizations translate principles of ethical AI into practice? So what are AI ethics or ethical principles? Well, as stated earlier, AI ethics includes ethical AI principles such as fairness, privacy, accountability, transparency, and explainability, and some guidelines and frameworks how to implement these in practice. But in order for the principles to be useful in practice, they must be able to guide actions. It is not enough to just understand the principles. You also have to know how to address them. This has led many national and international organizations to develop expert committees on AI, such as the European Commission's high-level expert group on AI, and the OECD expert group on AI, and Singapore's Advisory Council on the ethical use of artificial intelligence and data. They have all issued guidelines and other documents on ethical AI and AI governance. The European Union has been active on this field with the recent Artificial Intelligence Act proposal and their ethics guidelines for trustworthy AI. The guideline suggests that both technical and non-technical methods are required for AI principles to be implemented. Few of the technical methods include bias mitigation, continuous monitoring, and rigorous testing and validation of the system. And some of the non-technical methods consist of standardization and certification, impact and risk assessments, governance frameworks, education and awareness building, and diversity in AI design and development teams. To shed light on the research question, we have undertaken a set of expert interviews in organizations deploying AI systems. The empirical data was collected through 13 semi-structured expert interviews representing 12 organizations operating in Finland. The interviews were conducted in October and November 2020 via Zoom and MS Teams, and they were recorded, transcribed, and analyzed following the GEO method. We used purposeful sampling and focused on organizations that are forerunners in AI development. AI production is an ecosystem with multiple stakeholders involved in the development, deployment, and use of the actual system. Thus, we decided to include the different stakeholders involved in the AI ecosystem. The organizations either had AI systems in the organization's own use or as a sales product, created AI systems for clients, or provided AI-related services. 4 of the interviewed organizations were in the public sector and 8 in the private. Since the study concerns organizational practices, we considered management-level experts directly involved in AI development and deployment as the most appropriate informants for the interviews. The informants represented a range of managerial positions from CEOs to lead data scientists. Table 1 provides additional information about the informants. The participation was entirely voluntary, and the informants were assured anonymity. This created an opportunity for the participants to talk freely and describe their own experiences without being worried about leaking confidential information. The interview questions focused on how organizations addressed the ethical concerns and AI principles presented earlier, and they were adjusted as new knowledge emerged from the interviews. Examples of the interview questions include which measures, mechanisms, and practices are carried out to ensure the fair and ethical development, deployment, and use of AI systems, and how would you say is accountability for AI delegated at your organization? The informants were encouraged to discuss these with their own terms and concepts. The idea was to avoid the excess use of existing terminology and practices to discover new concepts and best practices. We use the GEO method to guide the analysis process for two reasons. First, it provides a systematic guide on how to code the data. Second, it focuses on creating a data structure that visualizes the analysis process. Each interview was recorded with the informer's permission and later transcribed for data analysis. The transcripts were then coded using quality research software NViva. Coding analysis were performed in 4 stages. The analysis began with open coding by reading each transcript and generating initial and in vivo codes. The research questions were used to guide the first route of coding. In the second stage of the analysis process, axial coding, similarities and differences were identified among the initial codes to reduce the number to a more manageable level. Moreover, these first-order codes were refined according to our evolving understanding and organized into second-order categories by similarity in content and logical connection. The second stage of the analysis process resulted in 28 first-order codes and 8 second-order categories. In the third stage of the analysis process, selective coding, the second-order categories were examined for underlying connections at a higher level of abstraction and distilled even further into aggregate dimensions. This stage led to 4 aggregate dimensions and a data structure representing the research results. Finally, in the fourth stage, the results were compared with the relevant literature to see how they relate to each other and whether new concepts had been discovered. As a result of the analysis process, we identified that ethical AI principles are implemented through 4 sets of practices, namely governance, AI design and development, competence and knowledge development, and stakeholder communication. These 4 aggregate dimensions consist of 8 second-order categories, namely data governance, AI design, MLOps, education and training, research, AI and data understanding, and AI and data communication, each comprised of a set of ethical AI practices. The first dimension, governance, refers to the set of administrative decisions and practices organizations use to address ethical concerns regarding the development, deployment, and use of AI systems. The governance practices consist of data governance and AI governance. While the governance dimension outlined the higher-level ethical AI policies and practices, the second dimension, AI design and development, refers to the set of practical methods and practices. The AI design and development practices consist of AI design and MLOps. The third dimension, competence and knowledge development, refers to the set of practices used to promote the skills, know-how, and awareness required to implement ethical AI. The competence and knowledge development practices consist of education and training, research, and AI and data understanding. The fourth and last dimension of ethical AI practices, stakeholder communication, refers to the set of communication practices organizations use to inform about their ethical AI practices, algorithms, or data. The stakeholder communication practices consist of AI and data communication. As our contribution to information systems research, we empirically elucidate how the principles of ethical AI are translated into organizational practices. Collectively, our results point out that the implementation of ethical AI goes beyond technical methods, includes several governance practices, and includes various stakeholders. In doing so, our results underscore the importance of a socio-technical perspective, balancing the benefits and risks related to organizational AI deployment. Moreover, our findings align with prior research in highlighting the role of practices such as risk assessment, competence development, and cross-functional collaboration. In addition, we extend on Meyer and others by underscoring and further elucidating practices related to data governance, MLOps, and AI design. Finally, our findings imply that the large-scale implementation of AI standards, certificates, and audits, as well as explainable AI systems, is yet to happen. This would suggest that the field is in a formative stage. For IS practice, we provide organizations deploying AI with novel insights on how to govern their AI systems. Due to the empirical and qualitative nature of this research, the results are limited to the data available and are subject to interpretation. However, the limitations of this study provide opportunities for future research. First, the study was conducted in Finland and the data was collected from organizations considered frontrunners in AI. Future research could expand the scope of the inquiry to other contexts. In addition, future research could focus on a specific company, industry, or application area of AI. Second, AI governance and the implementation of AI ethics is in a formative stage. Therefore, the results are bound to this specific time. Ethical AI practices and AI-specific standards, certificates, and audits, as well as explainable AI systems, are just beginning to take shape and be commercialized. In addition, the regulatory landscape is in a formative stage. Therefore, it would be insightful to study the developments and progress of the field. Third, the current study and the respective results focused on governing AI at the organization deploying the AI system. However, the AI development, deployment, and use often takes place in an ecosystem transcending organizational boundaries. Thus, future research could focus on examining the inter-organizational activities related to AI governance. Fourth, future research could examine to what extent existing tools and frameworks for example, IT governance and data governance apply to AI. That concluded my presentation. If you have any questions, my colleagues Teemu Birkstedt, Matti Mäntymäki, and I are happy to take them. Thank you for listening.